Okay, so here we have Journal 55, and we're going to be talking about multiplying matrices in this video, and also something about finding determinants. But let's get started by starting off with a story problem. And you'll notice the story problem is very similar to the last spell work that we did, and also very similar to the project. So here, I have that chart again, but this one's just about week 1. So these are the quantities that I sold on Monday, Wednesday, and Tuesday for pies, lemon pie, apple pie, and Hershey chocolate pie. And it says here, if Miss Chang sells her lemon pie for $1 a slice, $2 for apple pie, and $3 for Hershey chocolate pie, then how much money did she make total for each day? So it wants to know, how much money did I make on Monday, Tuesday, and Wednesday? Well, how can you find that with just, basic math? Well, if you think about it, if you know the prices of the pies, right, for each type, then you can take the quantity. So let's just focus in on Monday for a sec. So if I wanted to know the total amount that I made on Monday, like how much money I made on Monday, wouldn't I just take the type of pie, the number of pie, and multiply it by how much it cost? So 7 lemon pies times $1, 5 apple pies times $2, and 6 Hershey chocolate pies times $3, and then add them all up to get how much I made on Monday. And then I would do it for Tuesday and Wednesday, right? So that's exactly what I'm going to do here. So what I'm going to do is make it a little bit more organized by writing it as a matrix. So I'm just going to grab this here as my matrix because this represents my quantity of my pies. So week 1, I have 7, 5, 4, 5, 8, 3, 6, 4, 7. And so this represents week 1. And so looking at this here, I'm going to be multiplying it by its prices. So you know what? I'm going to make a new matrix, and this is just going to represent prices of the pies. Actually, I'll write that out. So this is going to be the price of pies. And so the price of my pies is $1 for lemon, $2 for apple, and $3 for Hershey chocolate. And so if I multiply this matrix, let me just find Monday, and then I'll find Tuesday and Wednesday. So for Monday, that would be taking these sets of numbers, the prices multiplied by just this column. So like I said before, I'm going to take my $1 and multiply it by my 7 pies. So 1 times 7 plus $2 times my 5 apple pies plus my $3 times my 6 Hershey chocolate pies. So if I multiply all this, let's see, 7 times 1 gives me 7, 2 times 5 gives me 10, 3 times 6 gives me 18. If I total this all up, I get 35. And so it looks like I made $35 on Monday. So you know what? I'm going to put this back in a matrix. So I'm going to write a matrix here, and this is going to represent Monday, Tuesday, and Wednesday, and I just found Monday, which is $35 that I made. Okay, but now what if I want to find Tuesday? Well, I would just do the same thing again, only this time around, I'm not going to be wanting to multiply this column, right? I'm going to be needing Tuesday's column. But I'm still going to be using the price matrix. So here's what I'll do. I will take my price and multiply it by my Tuesday quantities. So here I go. So that's going to be, let's see, 1 times 5 plus 2 times 8 plus 3 times 4. So if I multiply this all out, 1 times 5 is 5, plus 2 times 8, which is 16, plus 3 times 4 is 12. So if I add all of this up, let's see, that'd be 21 plus 33. 33 pies. I'm sorry, not 33 pies, $33. And then next, I'm going to take my last column here and multiply that out. So in this case, let's see if I grab another highlighter. Take this, that's not a highlighter, and multiply my third column. And so that's going to be 1 times 4 plus 2 times 3 plus 3 times 7. And so that's going to be 4 plus 6 plus 21. If I add this together, I get $31 for Wednesday. And so this is going to represent how much I made, or this matrix is going to represent how much I made for each day. So if I were to total this up, this would actually tell me how much I made that entire week. Okay, so I hope that helped. This is a great example to look at if you're doing your project and you need to figure out how to multiply matrices. So using prices and the quantity of your charts, you can multiply that and get, in this case, the total revenue for each day. Okay, so now let's take a look at multiplying matrices and looking at the definition for multiplying matrices. Okay, so let's now look at multiplying matrices. So when we multiply matrices, there's a few things that we need to know. One, we need to know the dimensions of the matrices that we're multiplying. So let's say we have two matrices here. I'm going to find the size of this matrix and this matrix. Now, obviously here, I don't have the matrix drawn out, but let's just pretend that this matrix has this as a dimension, and then we have another matrix with this dimension. Now, if you remember from last time, we learned that we always write rows and then columns. So kind of just a reminder here, we always write rows by columns. So here's the thing. It says you can only multiply matrices if their inner numbers match. What that means is you take a look at their dimensions. So this is their inner dimensions, so the inside dimensions. So the inside dimensions have to be the same number, so they must match. If they do, that means you have permission to multiply the matrices. If they don't match, then that means you can't multiply the matrices and it's undefined. And let's take a look at the outer matrix. So the outer matrix in this case is going to be the M and the P. So inner, outer. So the outer matrix actually tells you the results of the size of the matrix after you multiply. So here's what I mean. So in this case, you have M by P, so when you multiply these two matrices, this new matrix is going to be M by P in its size. So I'm going to show you that here in the next example. And when we multiply matrices, we always multiply rows by columns. So keep that in mind. All right, so let's multiply some matrices here. So first thing you always want to do is figure out what's the size of your two matrices that you have. So you're trying to multiply these two matrices. So this matrices here, or this matrix here, is 1 row and 2 columns. So this is a 1 by 2. Now I'm going to, actually I'm going to do that in red. Yeah, sorry about that. 1 by 2. And then this matrix here looks like we have 2 rows and 2 columns. So this is a 2 by 2. We also call this a square matrix. Square matrix means that you have the same amount of rows with the same amount of columns. So your columns and rows are the same amount. And also when the rows and the columns are the same, you have like a square shape matrix. You can think of it that way, because squares have the same sides, length. Okay, so back to this. So it looks like we have a dimension of 1 by 2 and 2 by 2. So remember what we said in the definition or the rules for matrices multiplying. The inners have to match, and they do, right? Because in this case, our inner is a 2, sorry, that should have been a highlighter, a 2 and a 2. And our outer is a 1 and a 2, so that tells me when I multiply these two matrices, I should get a 1 by 2. So that means 1 row and 2 columns. So I'm going to make some space for that. So looking at this here, I need to figure out what goes in my matrix here. If you remember from the last journal, you can figure out how many elements are in the matrices if you multiply your dimensions. So 1 times 2 is 2, so that means I have 2 elements inside this matrix. So you should have 2 numbers. So we're going to go figure out what those 2 numbers are by multiplying our rows by our columns. Let me repeat that again. When we multiply matrices, we always multiply rows by columns. So this is how I'm going to do things. I'm going to take this row, grab a highlighter here, take this row and multiply it by this column. You use this row, so the first matrices you use the row, and the second matrices you use the columns. And you multiply the rows by the columns until you run out of columns. So this is how we multiply. We're going to multiply the 9 with the negative 2. So 9 times negative 2 gives me negative 18. Plus, because we always add after we multiply, negative 2 times 6, which is negative 12. So here's what happened. When you take the row and multiply it by the column, you're going to take the first number in that row and the first number in that column and multiply them. That's how I got the negative 18. Then you take the second number in that row and the second number in the column and multiply them, and that's how I got the negative 12. And after you're multiplying them, you add the numbers up. So in this case, I'm now going to do it for the second part of the column. So this column here is going to need this column. So I'm done multiplying with this guy. I'm going to erase that. And now I'm going to multiply my second column. Sorry, that should have been a highlighter. But I'm still going to use the same row. So again, I'm going to multiply the first thing in this row with the first thing in this row. So 9 times 4 is 36. Plus, because we always add after, negative 2 times negative 7, which is 14. So if I total each element up, negative 18 plus negative 12 gives me negative 30. And then if I add 36 with 14, I get 50. And if you look here, I have definitely a 1 by 2. And I've simplified all I can. So this is my answer. So I've multiplied the matrices. So what I did there was I took the row, so your first matrix, or the matrix in front, you use the rows. This matrix here, you use the columns. So I take the first row and I multiply it with both columns separately. So this number came from the first column, this number came from the second column. From there, I try to simplify it down to get to here. So I'm going to try to do that with part B. So first thing we have to figure out is the dimension. So this one here is 2 rows, as you can see, and 2 columns. So this is also a 2 by 2, so another square matrix. And then this next one here has 2 rows and 3 columns. So this is a 2 by 3. Well, you can see here that their inners are the same. So if their inners are the same, that means that we can multiply them. And remember, the outer of the dimensions tell us our size of our new matrix when we multiply. So this here we have a 2 by 3. So that means 2 rows and 3 columns. So I'm going to try to make some room here. I'm actually probably going to need more room than that. So looking at this here, let's see. I'm going to take, remember, the first matrix, you want to use the row. So this is the first row. And we're going to multiply by the second matrix, you only use columns. So the first column, we're going to start that off. Oops. So that means I have to multiply the first number in this row with the first number in this column. So 1 times 4 gives me 4. Plus negative 3 times 5, which is negative 15. And now I'm done with this element here. I'm going to move on to the next one. So that means I'm done with this column. I have to move to the next column. I'm going to erase that. So 1 times 3 gives me 3, plus negative 3 times negative 4, which is positive 12. And I'm done with this column. Now my last column, I'm going to do again 1 times 2, which is 2, plus negative 3 times 7, which is negative 21. Sorry, that looks a little squished. Okay, and now it looks like I've multiplied every column that's here, right? That's the last column. So that means that I need to move on to my next row. And also when you look here, you'll notice that you filled in all of the columns, right? This is a 2 by 3, so that's all there now. So you're on the second row. So that's why we need the second row here. So I'm going to erase this, and now I'm going to highlight my second row here. I'm going to erase this guy, and we're going to start out with the column. Okay, so now I'm going to do 2 times 4, which is 8, plus 2 times 5, which is 25. Next, I'm going to now need to multiply by the next column. So that's going to be, let's see, 2 times 3, which is 6, plus 5 times negative 4, which is negative 20. And last but not least, I'm going to multiply positive 2. Let me use a highlighter so I can highlight that spot, just so I can stay consistent. So I'm going to multiply by the third column. So 2 times 2 gives me 4, plus 5 times 7 gives me 35. Now I'm going to add up all my numbers to figure out what's that number for each element. So in this case, let's see. 4 plus negative 15 gives me negative 11. The next one here, 3 plus 12 gives me 15. The last one, we have 2 plus negative 21 is negative 19. And then the second row here, we have 8 plus 25, which is 33. And then 6 plus negative 20 is negative 14. 4 plus 35 is 39. And there we have our new matrix. So I'm going to highlight that. So that's my matrix after I multiply. I also want to mention this if you haven't noticed it yet. So let's say you wanted to figure out what is the element, or like what number should be like here, okay? So notice that this is the second row, second column. So if you wanted to figure out this number just like randomly, what you would do is you would look back at your two matrices, and because this is the second row and second column, that's the location, you have to multiply the second row by the second column, and that's how you can get that number. So based off this number here tells you where it comes from, like what row and column you needed to multiply to get that number. So like this one here, if I wanted to get that 15, that is the first row, second column. So I need to multiply the first row with the second column, and that's how I get the 15. Okay, last one here, we're going to, I think I messed up here. Let's put that 3 back. Okay, so this last one, let's add in the dimensions. So this is a 2 by 3, 2 rows, 3 columns. And this one's a 2 by 2. Ooh, another square matrix. Okay, so if I multiply these two, wait, I can't, right? Because the inners, this one's a 3, this one's a 2. That's a mismatch. So in this case, I can't multiply it, so we say that this is undefined or no solution. Because the inners are not the same numbers, we can't multiply these two, so we say it's undefined. And if you guys like look and try to do it, like let's say you weren't paying attention and you just tried to do it just like we normally would, you would multiply rows by columns, you will notice an issue. You do 2 times 1, which is 4, 3 times 2, which is 6. But then when you get to this 2, who do you have to multiply? Nothing, right? This 2 is missing something to multiply, and that's the problem. This here doesn't have enough rows to multiply with this number of columns, and that's the issue. And so that's why you can't multiply matrices that don't have the inner dimensions the same. So I hope that helps out with multiplying matrices. Let's now take a look at what we call determinants, and that'll be the last thing we need to cover. Okay, so finding determinants is probably one of the most easiest things here, so I'm going to explain it to you. Finding determinants for a matrix only works for a square matrix. Now, you've been hearing me talk about square matrix. That's when the rows and the columns are the same. Now, for us, in this unit, we are only going to be looking at 2 by 2s, okay? So 2 rows, 2 columns. So here I have just a typical general idea of a 2 by 2 matrix. And it says here we use 2 vertical lines to represent a determinant of a matrix. So if I want the determinant of a matrix, I can use these vertical lines to show that, hey, I want the determinant of matrix A. So this is the formula, and basically all it's saying is that you multiply your A with your D. So if you look here, this is A, this is D, and we multiply. So how I like to think of it is that I multiply diagonally to the right. Let me use a highlighter there. Diagonally to the right. So if I draw an arrow, notice I'm going down right. And so I multiply my A with my D, so I always multiply diagonally to the right first. And then I multiply diagonally to the left. Notice B times C would be like going this way, so diagonally to the left. And then I subtract after I multiply. So here's what I mean. See this problem? There's straight lines here, so it's asking me to find the determinants of this matrix. So if I were to do that, let's set this up. This would be multiplying the 2 with the 7, because you always want to multiply diagonally to the down right first. So 2 times 7 gives me 14, minus the negative 9 times 6. So you go diagonally to the left, and that's going to give you negative 54. And if I were to subtract these two numbers, well, there's 2 negatives here, so that makes a positive sign. And so 14 plus 54 gives me 68, and that is my answer. When you find a determinant, it's always just a number, one number. So it's not a matrices anymore. It's not a matrix anymore. It's a number. So we're going to do that here. Again, remember, we go down to the right first. So down right. I keep grabbing the pen and I need the highlighter. There we go. And so in this case, we have 1 times negative 3 is negative 3, minus, because we always subtract, and then I'm going to highlight or multiply down to the left. So 10 times 4 gives me 40. So I have negative 3 minus negative 40, which is negative 43. So that's my determinant of that matrix. And that's it. So I hope this helps you out with page 2 of the packet. But yeah, that's Journal 55.